United States Military Academy, this is Mission Control Houston. Please call station for a voice check.
Station, this is Lieutenant Colonel Diana Laux. How do you hear me?
Hi, Lieutenant Colonel. This is Colonel Mark Vande Hei. I hear you loud and clear. How us?
We hear you loud and clear as well. Over. Okay, at this time, I'd like to introduce Colonel Ed Nasons, who is the head of the Department of Physics and Nuclear Engineering, for a few opening remarks.
Well, crew of the ISS, it is really great to see you. Well, thank you for this great opportunity. My name is Colonel Ed Nasons. I'm the head of the Department of Physics and Nuclear Engineering. If you spell out that acronym PANE, I'm the head of the House of Pain. And you know we have fun with that. Well, first of all, I'd like to say, usually there's a delayed response to that. First of all, let me say we hope that you all had a great Thanksgiving for you and your families. I saw pictures of your Thanksgiving dinner, and I believe I may have had it better with MREs in Afghanistan. Those little cubes, there's just no way you can make those cubes look like a turkey. I think you're pretty brave for trying out that food. Well, in the season of thanks, we certainly thank you for your continued inspiration of cadets, staff, and faculty at West Point, and to the world. Mark, you were an inspiration as an assistant professor in the Department of Physics and Nuclear Engineering, and you continue to do so from the International Space Station. We thank you and we thank NASA for what you do every day, advancing technology and pioneering aeronautical travel into space. We thank you for your bravery in accomplishing the ISS mission. We also thank you for the opportunity to ask you questions, knowing just how busy you are every single day. So today we have cadets from our core physics program and our newly created space science major and minor, which we are offering for the first time to the class of 2020. We are teaching 4 new courses in the major to include aeronautics, space science, astrophysics, and astronomy, and integrated with science, engineering, and humanities, will offer a great foundation for our next generation of Army space cadre, and maybe for future astronauts. We're also fortunate to have here today the Dean of our Academic Board, Brigadier General Cindy Jebb. Now, the lecture hall is packed, and we are ready and eager to engage with you. So let me say thanks again. Thanks again for all you do every single day. We appreciate your great sacrifice. You certainly have the right stuff, to steal a cliche, but you represent what right looks like. And we thank you for this great opportunity. So what I'm going to do now is I'm going to turn it over to Lieutenant Colonel Laux, who will introduce the questioners, and we'll get on with the question and answer period. But again, welcome to the House of Pain. It's great to see you. Thank you.
So, gentlemen, we'll begin the question and answer session. The cadets will come up one by one, and we look forward to your responses.
Gentlemen, I'm Cadet Adrian Barraza, and this question is for Mark. Sir, what is your fondest memory of West Point?
My fondest memory of West Point is actually over the summers going to the concerts on the just on the edge of the plain there, hanging out with my family, and really enjoying that beautiful place. I know as cadets you don't get to appreciate it quite the same way that assistant professors and professors do, but you really are in an amazing part of the country, and you're very fortunate to be at that place right now.
Gentlemen, this is Cadet Liam Fulton. This next question is for Randy. And sir, my question is, what is the most challenging part about being an astronaut?
Obviously, as a Marine, the biggest challenge is working with Army people. I figure I get to say that. My father was in the Army, so each generation tries to improve on the previous one. So, you know, I get to make comments like that. But really, it's nothing different than what you're facing right now, especially for those that are starting out at West Point. It's time management and multitasking. We have such a myriad of things that we do every day, and they're no 2 days are the same, and the tasks are so varied from unloading a cargo vehicle that we just grappled last week, to doing a medical experiment on a machine that's measuring how much your muscles can do, to growing plants like Joe did up here, growing lettuce. It is amazing how much different stuff we do, and you may not have recency of training, but you've got to be able to approach that task, be very thorough in it, and if you're, on time, great. If you're ahead of the clock, even better. If you're behind, you still got to pay attention and not worry about rushing off to your next task, because you got to finish the one that you're working on properly. So that's probably the biggest challenge we face up here on a daily basis.
Thanks, sir.
Cadet Chad Penny, this question's for Joe. How has living in a microgravity environment affected the physiological processes of your body, and what do you do to combat these effects?
I think this is going to be one of the toughest interviews that we've had with these questions you guys are sending us. But, of course, some of the big things we're looking at is muscle atrophy and the loss of our bone density. So we work out for a couple of hours every day, which is kind of nice to have that on your schedule. We have resistive exercise, and it feels just like you're lifting weights back at home. We also have a treadmill and a stationary bike, so we use those on a daily basis. We're learning a lot still about the body. We're having some issues with our eyes, so we're studying that as well. The digestive system seems to work pretty well for most of us, so the body adapts pretty well.
Thank you, sir.
Gentlemen, Cadet Stephen Scott, this question is for Mark. How did your experiences in the Army, especially overseas, affect your leadership style and the decision to become an astronaut?
That's a great question. The first thing I would say is leadership-wise, my experience taught me that there are lots of acceptable solutions to any problem typically, and by empowering your soldiers to pick the solution that's a feasible one that they're invested in and they chose, you can really get a lot accomplished, and people enjoy executing the plans that they have worked so hard to make up. It's also taught me that we have a lot more potential than we sometimes believe, and especially at your age, there's a limitless possibilities out there for you, and most people, I think, don't maximize that potential, but recognize that don't ever self-limit yourself. Go ahead and keep pushing forward and say yes a lot when those opportunities arise.
Thank you, sir.
Hello, gentlemen. Cadet William Morningstar, and this question is for Randy. What does it feel like to go outside the space station and fix something? So, like, what does the sun feel like?
It's a pretty neat, rewarding opportunity to go outside, and you're in your own personal spacecraft, and the only thing that is visually different is that instead of looking out a window like you're in an airplane, imagine now, instead of looking out that window, you jump out of the airplane, you're skydiving, and now the whole peripheral vision and your whole sensor suite visually is now what has the view of the Earth instead of looking through a window, and so you get that from the spacesuit. You're hanging underneath the space station, and the only thing between you and the Earth is your boots, and so you have these physical sensations of overcoming that physical fear of falling as you go ahead and go do the work. You don't necessarily feel the sun. The suit does a really good job of keeping it a constant temperature, and you can adjust it if you're getting a little cold during the night passes, or increase the cooling during the day passes. But to fix the piece of equipment outside is a very rewarding situation. Sable and I were out there on our first EVA here a little over a month ago, and we took the grappling part, the latching end effector of the robotic arm, and had to replace one of those. Pretty important, because that latching end effector is what allows us to grab visiting vehicles, to berth them to the station, to get the cargo and supplies that we need to be able to sustain the mission of the space station. So when we finished that partway through the EVA and they were doing the checkout, it was, one of those things where you want to be able to spike the ball and do the touch, the dance down in the end zone, but you still got other tasks to do, and you need to maintain your composure and maintain focused on the job. But that's the way it felt once we got that done, that we had done something really helpful to make Space Station be able to have a better capability in the future.
Thank you, sir.
Good morning, gentlemen. Cadet Kavan Moreau. My question's for Joe. I wanted to know, what are some of the effects that you experience after spacewalking, after an EVA, on your body?
Yeah, like Randy said, hunger. So we get into the suit a few hours before we even go outside, and then you're outside for anywhere from 6 to maybe 8 hours. So it's a long period of time. We do have some drinking water, but no food, so you're definitely hungry when you get back. But you're also physically tired. I know even the next day when it was time to work out, I was worn out. I felt tired. You're inside of a pressurized suit, so you're having to fight that pressure. But apart from that, there's also a pretty severe mental fatigue, because you're out there for this long period of time, and every action that you take is important. Whether you're just moving from one location to another, or you're installing something, you've got to focus on all of that. So imagine everything you do for over 6 hours, you have to be very, very deliberate. When you get back, your brain is tired. So as tired as my body was, I might have been more mentally fatigued as well.
Very interesting. Thank you, sir.
Gentlemen, Cadet West Pullis. This question is for Mark. What was it like your first day on the space station?
So Comrade was alluding to the fact that we started off very, very busy when we got up here. However, what I think he might not remember is the first 24 hours after we got here, I was supposed to rest. And I was so excited to be up here that I didn't rest at all. You can imagine spending about a decade really training for this moment. I'm finally on the space station. I could not possibly get myself to close my eyes. Comrade took me over to the window, got me to look out and see the horizon of the Earth, and that beautiful jewel in this complete blackness of space shining in the sun. It was really hard to take it all in. And then the next day, I was chasing the timeline and working my butt off, feeling like I was trying to learn how to walk again, and trying to keep track of my stuff, which is hard enough to keep track of when you can put it on the ground, but when you put it on the ground and it floats away someplace when you turn your back, it makes it a lot harder.
Thank you, sir.
Good morning, gentlemen. Cadet Matthew Volpe. My question is for Randy. Of all the experiments you've conducted, which is your favorite and why?
Up here, we're not, scientists in where we're trying to discover things, and we're not like in a lab with a Bunsen burner mixing chemicals to come up with the new unobtainium or costoverunium substance. We're up here executing what experts on the ground, their experiments have been designed to do, and we execute the procedures up here. And so one of the ones that I got to work on a couple months ago was one where we are growing lung tissue, and up here in zero gravity it grows differently, and we were using different substances to go ahead and clean it out as it goes ahead and grows here in microgravity, and then fixing it so it could go down to Earth and be studied. Well, that particular lung tissue was being grown because it is being developed to have cancer-fighting abilities, and we, our previous crew member dubbed it cancer-seeking missiles, and so that was something that was real world application of something we're doing up here that hopefully will make life a lot better back on Earth.
Yes, sir. Thank you.
Morning, gentlemen. Cadet Iris Yu. My question is for Joe. How did you adapt to live in space, and vice versa? How did you adapt back to life on Earth? Is there a great difficulty in doing one or the other?
I think they both have their challenges, and what's neat about coming up here is noticing how quickly the body adapts to being in space. Of course, you have kind of the normal, what you can call space sickness, where your inner ear is not feeling right, the hairs don't know what to do up here in a microgravity environment, so you don't feel so great. Usually, my first 24 hours, I'm on the edge of getting sick, not quite getting sick, so not feeling 100%. But once that goes away and the fluid shifting goes back to a more kind of neutral state, it's almost like we were born to be in space. We talk about it often, how we want to get over there and we know how to push off, we know how to use our feet to hang on to things, and it's just a supernatural feeling. And then going home, when you land, you wonder, how do humans live on this planet? Because, that gravity, I don't know, you learn about gravity in physics, but it's strong after you've been up here for a few months. So even just moving your head and walking it's pretty difficult. But again, the human body is pretty amazing. And within, a few days, you're feeling really, really good. You're driving a car within a week. And in about that same time, you're out running outside. So they have their challenges, but the body is amazing how it adapts going in both directions.
Thank you, sir.
Hello, gentlemen. Cadet Michael Howard. My question is for Mark. Can you describe the Kestrel I mission and the role you played in it?
Sure. The Kestrel I mission was to see if there was an inexpensive way to provide imagery at as low a possible level to tactical commanders. My role in it was to, in fact, right behind us, we're in the Japanese module of the space station right now, and right behind us we have an airlock. There's a slide table that comes out. My role in it was to mount that satellite to that slide table and then transfer the satellite into the airlock, and then the ground control teams brought it outside, grabbed it with a robotic arm, and then the next day or two, I can't remember exactly, my job was to photo document and videotape the launching of that satellite from that robotic arm.
Thank you, sir.
Well, I guess our time is up, but I got to tell you something that was very informative. We really appreciate the time that you spent with us. And Randy mentioned the idea about making a touchdown and spiking the football. Randy, I just want you to know you're going to see that a lot when Army beats Navy here on December 13th.
Go Army, beat Navy.
So I just want to leave you one parting message, and from all of us to you, especially to you, Randy, go Army, beat Navy. Ooh-ah! Thanks again for all you do. You're a special people.
And sir, thank you, sir. It's wonderful to hear your voice again, and I really appreciate the privilege to be able to talk to you all today.
Station, this is Houston ACR. That concludes the event.
Thank you, all participants. With the U.S. Military Academy, station, please stand by while we reconfigure video and audio comm for your deferred release message.